Hi everyone and welcome to today's lesson. When we are given any two values or terms in an arithmetic series, we can actually calculate the first constant difference. In today's warm-up, we are going to learn a very important concept that is going to be useful to calculate the constant difference when we do not have consecutive terms. Now let me illustrate by means of an example. Here we are given term 1 all the way to term 10. Now all of these values or terms are consecutive terms, so it's easy for us to calculate the first constant difference because 8 minus 5 is a positive 3. Let's say we have term 4 and term 5. They are also consecutive terms. So I can easily say 17 minus 14 will also give me the first constant difference, which is a positive 3. What if we have term 8 and term 9? They are consecutive terms. So I can just simply say 29 minus 26 will also be the first constant difference, which is a positive 3. The problem comes in, or the challenge comes in, when we do not have consecutive terms. So I give you only term 1 and term 10. Because they are not consecutive terms, I cannot simply subtract 5 from 32 and say that is my constant difference. No, because there are 1, 2, 3, 4, 5, 6, 7, 8, 9 constant differences that I have to add to term 1. So that leads us to the following formula. We can say that term 10 is equal to term 1 plus 9 constant differences. Okay, let's see again. Term 1, which is 5 plus 1, 2, 3, 4, 5, 6, 7, 8, 9 constant differences will give me term 10. Okay, and for us to be able to see if we are correct or tested, we can simply say that that 1 plus the amount of constant differences, so 1 plus 9, gives us that 10. Okay, can you see? That's an easy way for us to test to see if we are correct. Now, what if I only give you term 7, which is 23, and I also give you term 3, which is 11? How will we write that in terms of a formula? We will simply say term 7 is equal to term 3 plus 4 constant differences. Let's test it. 3 plus the amount, which is 4, gives us the 7th position. And let's see, 11 plus 1, 2, 3, 4 constant differences will give us term 7, which is 23. Got it? Now let's see if you can do it by yourself. Let me give you term 8, which is 26, as well as term 3, which is 11. So we can write it as term 8 is equal to term 3 plus how many constant differences? Well, excellent. Yes, it's 5 constant differences. Let's see if we are correct. Term 3 is 11 plus 1, 2, 3, 4, 5 constant differences gives us term 8, which is 26. Now, let's try the last one. How about this one? Term 9, which is 29, and I also give you term 2, which is an 8. So we can say term 9 is equal to term 2 plus how many constant differences? 7 constant differences. Excellent, because 8 plus 1, 2, 3, 4, 5, 6, 7 constant differences will give us 29, which is term 9. So we are going to make use of all of this information to calculate the first constant difference when we do not have consecutive terms. Arithmetic series, which is A 13, B 27, and so on. And I told you that this is an arithmetic series, so we know that it has a first constant difference. Now in the warm-up, I said something very important, that if we are given an arithmetic series with any two values in it, we can actually calculate the constant difference. So let's see what the question is in this case. They ask us to calculate the values of A and B. So they want us to calculate term 1 as well as term 3. Now to do that in an arithmetic series, we are going to need the first constant difference. Now to get that in a series where we are given two terms, we are given term 2 and we are given term 4, we can simply use the formula that the term 4 is equal to term 2 plus 2 constant differences, because 13 plus a constant difference will give us b, and b plus a constant difference will give us 27. So 13 plus 2 constant differences will give us 27. And then we simply do substitution. In the place of term 4, we will put 27, and in the place of term 2, we will put 13. And then it looks like this. 27 equals 13 plus 2 constant differences. And that's true, right? Because 13 plus a constant difference plus another constant difference will give us 27. Then we take this constant to the other side, because that's the way we calculate equations. And then it looks like this. 27 minus 13 equals 2 constant differences. That gives us 14 equals 2 constant differences. And if we take this 14 divided by the coefficient, we get an answer of 7. So our first constant difference has a value of 7. Now it's quite easy to go from here and get the a and the b, because a plus 7 must give us 13. So here it is. A plus 7 equals 13. And then to get the a, we simply say 13 minus 7 is 6. And there we go. So term 1 is a 6. And if we want b, we will simply say 13 plus 7, which will give us term 3. So 13 plus 7 equals 20. And our term 3 is equal to a 20, which is our b here, right? So let's look at this again. 6 plus 7 gives us 13. 13 plus 7 gives us 20, and 20 plus 7 is 27. And there we go. We just calculated this arithmetic series. So you learned something very important today, that if you are given an arithmetic series with any two terms, it is easy to calculate the first constant difference, and then we can get any other term in the sequence.